For thousands of years, the planet was slowly emerging from the grip of the Ice Age. Massive glaciers were retreating, ecosystems were expanding, and Earth seemed to be entering a warmer and more stable climate. Then something extraordinary happened. Without warning, the warming stopped. Temperatures plunged. Within a short span of time, the northern hemisphere was thrown back into near-glacial conditions. Entire ecosystems collapsed. Weather patterns changed violently, and scientists today still struggle to explain one haunting question: what could cause Earth's climate to reverse so suddenly? The answer may lie in a mysterious event that occurred around 12,800 years ago, an event now known as the Younger Dryas. Long before modern science began examining ancient ice cores or geological sediments, many civilizations told stories about a time when the world nearly ended. Across continents and cultures, myths described fire falling from the sky, massive floods, and sudden destruction that forced humanity to rebuild. These stories appear in ancient traditions separated by vast distances and thousands of years. For centuries, they were dismissed as symbolic or purely mythical. But some researchers now wonder if these legends could contain fragments of something much older, distant cultural memories of real prehistoric disasters that shaped the early human experience. Modern interest in this mystery began when scientists studying deep ice cores from Greenland noticed something astonishing hidden in the frozen layers. Around 12,800 years ago, climate records revealed an abrupt and dramatic shift. Temperatures that had been steadily rising suddenly collapsed. The event was so distinct that it created a clear boundary in the geological record. This cold period lasted more than 1,000 years before temperatures finally began warming again. Scientists named this strange climatic interruption the Younger Dryas, after a cold-tolerant flower whose remains appear in European sediments from that time. Before the Younger Dryas began, the world appeared to be transitioning smoothly out of the last ice age. For nearly 2,000 years, global temperatures had been rising. Vast ice sheets that once covered North America and Northern Europe were retreating northward. Rivers and lakes expanded across landscapes that had previously been frozen wastelands. Plants and animals rapidly recolonized these newly habitable regions. Early human populations also began spreading across continents, following migrating animals and expanding ecosystems. Everything suggested that the planet was moving toward a warmer and more stable climate. Then, almost suddenly, the warming stopped. In what appears to have been a geological instant, temperatures across much of the northern hemisphere plunged dramatically. In some regions, the drop may have reached several degrees Celsius in only a few decades. For a planetary climate system that normally changes slowly over centuries or millennia, such rapid cooling was extraordinary. Landscapes that had begun thawing froze again. Glaciers advanced once more. Environments that had supported growing ecosystems were suddenly thrown back into harsh, unstable conditions. The most detailed evidence for this rapid climate shift comes from ice cores drilled deep into the Greenland ice sheet. These frozen cylinders preserve year-by-year climate records, stretching back tens of thousands of years. Within these layers, scientists discovered a sudden chemical signal marking the beginning of the Younger Dryas. The data suggests that temperatures may have dropped dramatically in a very short period of time, possibly within a single human lifetime. For researchers studying Earth's climate system, this speed of change was deeply puzzling. Something powerful had disrupted the planet's natural warming trend. As the cold conditions of the Younger Dryas spread, ecosystems across the northern hemisphere were forced to adapt rapidly. Forests retreated, grasslands expanded, animal populations shifted their migration patterns as habitats transformed. For early human communities already living near the edges of survival, Such sudden environmental instability would have presented enormous challenges. Food sources could disappear. Seasonal patterns could change unpredictably. Entire landscapes that people depended on might suddenly become unrecognizable. Scientists began searching for an explanation capable of triggering such a sudden planetary disruption. One explanation that eventually emerged was both dramatic and controversial. Some researchers proposed that Earth may have experienced a cosmic encounter around the beginning of the Younger Dryas. According to this idea, fragments of a massive comet could have entered the planet's atmosphere, producing enormous explosions and environmental destruction across large regions of the planet. If true, such an event could potentially explain both the sudden climate disruption and the unusual geological evidence found in sediment layers dating to this period. This idea became known as the Younger Dryas impact hypothesis. Unlike the asteroid impact that wiped out the dinosaurs millions of years earlier, this theory does not require a single massive crater. Instead, it suggests that a large comet may have fragmented as it approached Earth. Multiple pieces could then have exploded in the atmosphere or impacted different regions of the planet. These explosions, known as airbursts, could generate extreme heat, shock waves, and widespread fires across enormous areas. Airburst events are capable of releasing tremendous energy without leaving large impact craters. When a fast-moving cosmic object enters the atmosphere, it can explode before reaching the ground. The resulting blast can flatten forests, ignite fires, and send shock waves across hundreds of kilometers. The most famous modern example occurred in 1908, when an explosion over Siberia flattened more than 2,000 square kilometers of forest. But researchers studying the Younger Dryas believe the prehistoric event may have been vastly larger, possibly involving multiple explosions across several continents. To test this hypothesis, scientists began examining geological layers dating precisely to the beginning of the Younger Dryas. If a cosmic impact or airburst had occurred, it might have left unusual chemical or mineral signatures preserved within sediments. Researchers searched for materials that typically form only under extremely high temperatures and pressures, conditions associated with cosmic impacts rather than normal geological processes. What they found was surprising. In multiple locations across North America and Europe, sediment layers dating to the Younger Dryas boundary contained microscopic particles known as carbon microspherules. These tiny spherical particles form when organic material is exposed to extremely high temperatures and rapidly melt. Even more intriguing were the discovery of nanodiamonds, microscopic diamond structures that can form during high-energy cosmic impacts. Other unusual materials appeared as well. Scientists identified shocked quartz crystals, a form of quartz that develops distinctive microscopic fractures when subjected to extreme pressure waves. This type of mineral deformation is commonly associated with asteroid or comet impacts. The presence of these materials suggested that intense heat and shock events may have occurred at the very moment when the Younger Dryas climate shift began. Perhaps even more striking was the geographic distribution of these materials. Researchers began finding similar evidence in sediment layers spread across vast regions of the Northern Hemisphere. Sites in North America, parts of Europe, and the Middle East all contained layers dating to the same period, marked by the same unusual materials. If these findings were connected, they suggested that whatever happened at the beginning of the Younger Dryas may have been a global-scale event. One of the most intriguing discoveries connected to this mystery occurred at an archaeological site in northern Syria known as Abu Huraira. This location preserves the remains of an ancient settlement occupied by human communities thousands of years ago. When scientists examined the Younger Dryas layer at the site, they discovered something extraordinary hidden within the sediments. Embedded within the archaeological layers were tiny fragments of melted minerals and glass-like material. These substances appeared to have formed when soil and rock were suddenly exposed to extremely high temperatures. The melting pattern suggested a rapid and intense heat source, unlike the slow heating produced by natural fires. Laboratory analysis revealed that some of these materials may have formed at temperatures exceeding 2,000 degrees Celsius. Such extreme heat is difficult to explain through ordinary natural processes. Wildfires rarely reach those temperatures, and volcanic eruptions were not known to have occurred in the region during that period. The discovery raised an extraordinary possibility. The village may have experienced a sudden cosmic airburst overhead. If a comet fragment exploded above the region, the resulting shock wave and heat blast could have instantly devastated the settlement. A fireball streaking across the sky, followed by an explosion brighter than the sun itself, would have unleashed unimaginable destruction. For the people living there, the events may have appeared like the sky itself had erupted. If similar airbursts occurred across other regions, early human populations across large parts of the planet could have experienced sudden environmental catastrophe. Forests might ignite instantly, shock waves could flatten landscapes, ash and smoke could darken the sky. For small hunter-gatherer communities, survival would depend on rapid adaptation and migration. Yet, archaeological evidence suggests that humanity endured. In many regions, people eventually returned to previously devastated areas. Within a few generations, communities were once again building settlements and exploiting local resources. Despite catastrophic environmental conditions, early human societies proved remarkably resilient. At nearly the same moment the Younger Dryas began, another mysterious event unfolded across several continents. Many of the largest animals on Earth began disappearing from the fossil record. Species that had dominated Ice Age ecosystems for thousands of years suddenly vanished. Among the most famous of these animals were the woolly mammoths. Alongside them were giant ground sloths, saber-toothed predators, massive bison species, and other megafauna. Within a relatively short geological period, many of these giants disappeared entirely. In North America, the disappearance of these animals coincided with the decline of the Clovis culture, one of the earliest widespread human cultures on the continent. Archaeological sites associated with Clovis technology became rare or vanished entirely around the same time the Younger Dryas began. Scientists continue debating the cause of these extinctions. Some researchers argue that human hunting placed unsustainable pressure on megafauna populations. Others believe climate instability disrupted ecosystems too rapidly for large animals to adapt. But the timing has led some to suspect that catastrophic environmental event may have played a role. Additional clues emerge from sediment layers dating to the Younger Dryas boundary. Many sites contain unusually high concentrations of charcoal and soot. These materials suggest that massive burning events occurred across large regions during this period. Some scientists believe these charcoal layers may represent enormous wildfires ignited by the heat from cosmic airbursts. If multiple explosions occurred across continents, they could have ignited forests across vast areas simultaneously. Such fires would release enormous quantities of smoke and soot into the atmosphere. If enough material entered the upper atmosphere, it could block sunlight and dramatically alter global climate patterns. This type of atmospheric disruption could potentially trigger rapid cooling. The combination of atmospheric dust, widespread fires, and climate instability may have created a cascading chain reaction. Ecosystems would struggle to recover. Food sources would collapse. Animal populations would decline. The fragile balance of the post-Ice Age world could quickly unravel. Despite the dramatic nature of the impact hypothesis, many scientists remain skeptical. Some researchers argue that the evidence for cosmic impact materials could have alternative explanations unrelated to comet explosions. Other climate scientists propose that the Younger Dryas may have been triggered by changes in ocean circulation. Massive glacial lakes in North America may have suddenly drained into the North Atlantic, disrupting ocean currents that regulate global climate. The truth may lie somewhere between these explanations. New studies continue analyzing sediments, climate models, and archaeological records in an effort to reconstruct what truly happened during this mysterious period. Whatever its cause, the Younger Dryas represents one of the most dramatic environmental disruptions experienced by early human civilizations. Surviving such instability may have forced human societies to develop new survival strategies. Some researchers even speculate that the pressures of this unstable climate may have contributed to one of humanity's greatest transformations, the eventual development of agriculture and permanent settlements. More than 12,000 years later, the mystery remains unresolved. Did a fragmented comet ignite fires across continents? Did shifting oceans plunge the world back into ice? Or did multiple forces combine to reshape the planet at a critical moment in human history? The Younger Dryas stands as a reminder that Earth's past still holds secrets capable of changing how we understand the story of our own civilization.